So, hello everyone. Today I will share two papers about, say, explainability as a dialogue. Actually, the two papers are highly connected. You can take one as the you can take one as the prototype, another one as the instance. Yeah, let me show you about it. So the first paper, which provides a prototype of the explainability with dialogues. The authors identify a research type that most existing works. Although we have plenty of the explainable AI methods, most of them only provide, say, one-off static explanations like feature importance and something like, say, decision trees or something. But these actually are static explanations, and users of the explainable AI systems only receive static explanations for each local decision. However, the authors find they may have the needs to explore the system and interactively access why the AI systems reach the decision. Yeah, so in this paper, the authors carry out interview with doctors and healthcare professionals, policymakers about their needs and desires for explanations. And they summarize the pain points of users in the perspective of explainable AI. And then, based on these key findings, they propose that the dialogue to elucidate the explainability should be a promising future direction and also provide the challenges and the risks for the modulars. Uh, let's first show you an example of what's the explainability dialogues. So like in this case, it's a lung cancer prediction, and the users of the system see that, say, the input data contains a lady with more than 65, and the model predicts this guy with high risk for the lung cancer, and then he seek for the reason. The robot explains with the feature attribution and use this visualization to show that the is smoker and live in city is two very important features, which finally make the decision. And this a little surprise the users, and so he continued to ask. So I'm surprising that whether the person lives in a city is so important. And then the robots, actually, I think he uh, reply to this question with some explanation based on specific group, subgroup of the statistics. So this is just an explanation. So in this way, it's just like a dialogue we have every day, but actually they use, say, natural language response and also maybe sometimes some visualization, and in an interactive way to help the users have better understanding why this decision is made. So in the interview, they mainly invite 14 doctors and 12 policymakers. I think many of them have experience of using the explainable AI methods like Lean, Sharp, and some gradient-based explanation methods. The purpose of this interview is to understand how they use explanations in their day-to-day work and their pain points when their experience of using the existing explanations and what they would like to see in the next generation of explanations. So I think it's the say main experiment. Maybe you should call it this. The authors try to conduct, and the interview mainly contains, say, I think it's three or more than that, but the authors highlight the three aspects: users' perceptions about the strengths, weakness of the current explanations, and also they try to assess whether the users think dialogues to explain the explainability could help users better understand the machine learning models. Yeah, but I don't know whether the second point is how to say, too straightforward or something. Yeah, so they have many findings. The first one, the domain experts are not satisfied with existing explanation paradigm. And second one, domain experts would prefer, say, increased interaction with model about its behavior instead of just see one of static explanations, such as the ones provided by existing sharp, lim and sharp, or sentence maps. And third, the domain experts agree that interaction with models and explanations through natural language dialogues would be an advantage routes to more interactive explanations. Yes, actually, I think they point out this to support that the prototype explainability dialogues are good. And last, the experts also place a high value in the correctness of explanations. I think this is a good point that say, actually, we did provide explanations in many existing methods, but few of them provide the correctness, accuracy, or trustworthiness or something about this explanation. And the authors did argue that we should put much efforts into it. Yeah, and based on the interview results, they summarize 5 principles to design the interactive explanations or interactive explanation systems. The authors hope this can be a good, say, start point for further research. Yeah, and we will look at them one by one. The first principle, the system should understand continuous requests. That means whatever users input, the system should understand it and provide, say, appropriate, say, response according to the request. The second one is should respond with informative, contextualized, and satisfying explanation about why model makes specific decision. And the third one, the system should provide reliable notions and confidence along with explanations. Actually, this is just the one we mentioned at the last slide. And the fourth is that the system should reduce or eliminate the need for users. Actually, I think it can be broader. Maybe it's not only, say, writing code. Maybe it's just make users don't need to, say, have the technique background or domain knowledge or something. Make it very, say, clear, and users don't have too much cognitive load to work on it. And the last one, consider the context. I think it's mainly keep previous interactions, and this just presents the history as a dialogue way. Yeah. And they also point out some possible promising directions. First, they argue, say, the main prototype, interactive explanability with open dialogues. It's a promising direction. Yeah, and to be honest, we also try to work on something similar, but I think not exactly the same. And also the second one, they provide the accuracy and confidence estimates of explanations. I think this would be a very good direction, but to be honest, I don't know, say, how can we achieve this? Because according to my understanding, now we provide the post hoc explanations to the models, and then if we are supposed to provide the accuracy and the confidence for the explanations, you know what, it should be calibrated based on the, say, realistic scenario. I have to say, in my view, this would be very challenging. Yeah, because I don't have a very good idea how we can provide this. Yeah, and they also try to abstract the prototype explainability dialog into 4 modules. So basically, the natural language understanding module, that means given any user input, you can understand what users want to know. And the second one, explanation algorithm modules, that after you identify the user intentions, you need to know, say, which explainable AI methods to run. Yeah, and also after you run the explanation methods, you get some, say, maybe feature attribution or something, and then you should respond to the user requests appropriately. That means you need to turn the output or explainable AI methods into natural language response. So you may also need the response generation module. And finally, a GUI interface. Yeah, but in the, say, in the second paper, in the instance, actually they only highlight the 3 points, the top 3 points, not the last one. Yeah, and I also see that, say, actually in the first and the third modules, in the 2 modules, the main technique actually they involve in the second paper is pre-trained language model, and the explanation algorithm module is just, say, after you identify the intention, you need to, say, first make a choice of the explanation AI methods to run, and then just run it, get the results. Yeah, I would say actually in their perspective, I think the system is mostly addressed with automatic approach. That means the machine learning part, yeah, not the human in the loop part. So then let's look at the second paper. I will summarize the contributions at the end. And this paper is more like an instance of the prototype proposed in the first paper. And the motivation actually is close. So we may directly zoom into how they design this instance and how they provide the explainability-based dialogues. So the main workflow can be, say, visualized with this figure. So first, users will provide inputs, and that can be, say, about specific data. Say they want to know why model reach a decision, and say, what if we want to, say, switch the model prediction, how model will reach this, and then just input it. Model will identify, say, the operations required to answer this user queries. So actually this step, it can be, say, it can be just triggered as a text to SQL. Yeah, I think it should be a text to SQL. Actually, they also define the dataset specific grammars. We will see it later. Yeah, and then after the model actually understands the user requests, that means they translate this into operation into a logic form like this, and then model the system know how to execute these operations. That means they identify the explainable AI methods and then run it, get the output. Yeah, after they get this output, there would be a, say, response generator based on the output, and then generate the natural language response. So you can see they generate this response, I think, to the left one, this response to the right ones. So in this process, the information flow is user input, logic form, execution results, and finally response. Also, this one can be user utterance and user intentions, explainable AI explanations, and finally response. So it's a highly modular design. Yeah, and then this in the left, it's actually the grammar rules of the TalkToModel system. Actually, in the first step, user input the requests. They need to translate them into the executable logic form. So actually, they follow these logical rules. They have some description, machine learning. This is filter, explainability. That means I think it's explainable AI methods, and also this is show some statistics or operations on the dataset. So actually they provide this, but as we know, there is no uniform grammar rules for all datasets. So actually this grammar rules should be grounded with specific dataset, and also they call it dataset specific formal grammar. If you are interested, you may have a look at this paper. And I would say enabling context in dialogues, for me, it's a little strange because in my understanding, in the dialogues, you keep the context. And even for deep learning models, you may say model the conversation context. So for me, the second point don't make too much sense. And in the semantic parsing part, that means they try to translate the user requests into a logical form. Actually, they follow a semantic parsing. They call it a semantic parsing module, but actually they just train a sequence model. It can be, say, fine-tuned pre-trained language model like the T5, and also to ensure that the generated logic forms can be executable. So actually they obtain, say, constraint decoding. That means at each step of decoding, they have constraints that the generated sentence, the generated logic form must, say, be in the grammar. And also, I thought that they would generate the response with purely the large language models, but it seems they also adopt template-based response. Then let's look at how they evaluate the dialogue system. So they look at 3 datasets: the diabetes, a medical system; loan prediction, a finance system; and the race division prediction. It's it's about, say, criminal bill. It's something about this topic. And they did have some automatic evaluation. It's mainly for the first step. How accurate can the system translate the user queries into a perfect intention in the logic form? They annotated some data and they just try to compare their different, say, methods in this module, and they find that fine-tuned, say, T5 consistently better than the few-shot prompting methods. And actually it achieves quite good results in all datasets. I think it's within 60% to 80%. And they also have the qualitative user study to show us the utility of this system. In the qualitative part, actually they adopt the 4 dimensions: easiness, confidence, speed, likeness. But I think it's mainly, say, subjective attitude, subjective properties of the system users. They try to compare it with the existing, say, another very good explainable AI that's dashboard. That means, say, they also have some designs, but they provide, say, one of static explanations, but you can, say, customize your information need. That means maybe for each one you can ask for natural language explanation or some graphs or something. And their results show that their explainability dialogues receives much easiness, confidence, speed, and users are more likely to use it. And also they try to see whether this explainability dialogues help users reach better decisions, and they find that most users report lower uncertainty. I think this also is the report lower uncertainty. That means at the end, they don't think they couldn't determine the results is correct or not. So I think it's something like higher confidence. And also like in this, the accuracy of the completed questions, they show that the TalkToModel show much higher accuracy. Yeah, but for me, I would say it's a little confusing why they can choose 100% accuracy. Yeah, so for me, I think I believe they can be better, but I don't know whether there is so large gap because according to my experience, I'm relatively sensitive to the numbers report. So to be honest, I think they should be better, but I don't know whether there is so large gap. Yeah. Yeah, so let's summarize the takeaways from the two papers about the explainability dialogues. So first, I think in general, they point out the promising future direction, open dialogues for explainability. Yeah, and for the system, they provide both prototype from in the first paper and the instance in the second paper. This can help us have a basic understanding of this system or something similar. And the third one is the reliability, accuracy of the explanations. I think we can also think about it. If we have a very good solution, it can be definitely a very, I think, impactful work. Yeah. And also a point they find from the interview is that the practitioners also find that they need the subgroup network explanations. Yeah, for this, I explain a bit. You can imagine in a tabular dataset, for example, the long prediction ones, maybe the users want to know how the AI system think we should provide the loans to a specific subgroup, like the one who get maybe lower education or get have more have more house in the rural areas or something. Yeah, actually, practitioners also report this need. And also they provide some, I think, measures and baselines to compare different methods about the interactive explainable AI methods with existing ones. I think this would be also helpful. Maybe we may touch similar experiments. And also I did see that they show large language models play a powerful and play a key role in such systems. Yeah. So I think that's it. Do you have any questions?
I do have one. Can you hear me?
Yeah.
Yeah. Do you think it's realistic that so it's end users? I'm a little bit confused because in the healthcare one, we are talking about data domain experts, in this case, doctors. And
Yeah,
in the loan case, are we talking about clients who are going to be impacted by the decision, or
I think that this
workers?
is the policymakers, or in other words, it's employees of the bank.
Employees of the bank. Okay.
Yeah.
Okay, cool. Okay, that makes sense. Now, because we have been experimenting a little bit with end users, so no, not bank employees, but those who would receive the loan and blah, blah, blah. And I think it's not realistic to say they want to know the accuracy of the explanations, or it would be just too much. I think that's my personal opinion. But if it's the bank experts, then it might make sense.
Yeah.